Today, I've been talking about this program for a long time because I guess personally I'm really excited about hearing what Duane has to say. But Duane traveled all the way from the Academy to get up here to talk to us in person today. Duane is the Academy architect, and he's only done that job since 1983. And he's starting to get good at it now. But one of the things that really it's important to understand is that Duane's experience in this project is critical, because when he came on board as an architect at the Academy, he actually got to know and was mentored by a man who I'll let him tell you a little bit about that, because Duane is our linchpin right now to be sure that this historic structure gets restored back to the way that it was. How many people know that that this is the #1 man-made tourist attraction in the state of Colorado? I mean, it's huge. So with that, Duane is going to talk to us a little bit about things we didn't know about the chapel.
So first off, thank you for inviting me to come up and talk to you about our amazing project at the Academy. I hope you will enjoy the presentation. Not coming off yet. So what my presentation is going to cover is kind of the history of the design of the chapel, some of the inspirations and why the chapel is designed the way it is, the problems that it's had, and the project that we have ongoing today to fix those problems and return the building back to its original design intent. So to give you a little bit of background, the architect who designed the Cadet Chapel is Walter Nitsch Jr. of Skidmore, Owings & Merrill. And Skidmore, Owings & Merrill designed everything at the Air Force Academy. They planned all 18,500 acres, and they designed all the buildings at the Academy. Walter was actually in charge of the entire design effort for every building on the Academy, and he had different design teams working for him. But he actually personally did the chapel. It was completed in '62, dedicated in '63. In 1996, it won the American Institute of Architects 25-year award. That's given to one building every year that has stood the test of time and become a significant part of American architectural history. So it's a huge award for any project to get, but it's the only time that the federal government ever won that design award. It's #1 man-made tourist attraction, as was mentioned. And in 2004, the chapel, along with the entire cadet area, was designated a National Historic Landmark District, which is the highest level of historic designation that is offered in our country. This is a model of the cadet area when it was under design, and it was kind of the first serious look at what a chapel might be. Right there. It ran in a more traditional east-west orientation. So if any of you are familiar with the Academy, this is Fairchild Hall, Vandenberg Hall, our huge dorm, Arnold Hall, our student center, and this is an early version of the athletic complex. That kind of morphed into a very serious design, which was a folded plate structure clad in marble and stained glass. It actually sat one level higher than the current chapel does. The current chapel sits at this level, which is, we call it the honor court. This was up one level higher and ran also in a more traditional east-west orientation. And it had 3 chapels on one level. That became a very serious design proposal, but it also became a very serious issue as far as architectural controversy went. So for just a little bit of background on how the Academy was established. It was actually established at Lowry Air Force Base, but the Air Force made a commitment never to have a class graduate from the Air Force Academy that did not graduate from the permanent site in Colorado Springs. So that meant between 1954 and 1958, not only did a lot of design work have to get done, but there was a huge national push to actually get the buildings built so the class of '59 could actually be in the permanent site in '58 to graduate in '59. So because of the controversy on the chapel design, the Air Force and Skidmore, Owings & Merrill really didn't have time to deal with the chapel design. So everybody agreed to put the chapel on the back burner until the end of the project and then come back and design a different version of the cadet chapel, which you'll see here in a little bit. So because of that controversy, this was an editorial cartoon out of the Denver Post in 1955. which I thought was very appropriate. So when Walter had the design of all the other areas of the Air Force Academy under control, he decided he was going to take a short sabbatical and go to Europe and see which cathedrals in Europe would influence him in the design of a chapel for the Air Force Academy. And out of that, there were 4. And I guess I ought to say that I got to know Walter very well. I came from Skidmore, Owings and Merrill, and I spent about 2.5 decades with Walter, and we became very good friends. And I was back in Chicago all the time at his house, and I learned all about what his inspiration was in designing the academy and the chapel, why things are the way they are. So it's kind of first-hand information, which is really great to have. So it's 4 cathedrals that influenced him. One was Chartres, which was the flying buttresses on the outside. Notre Dame, which is the flying buttresses, and the height of Notre Dame before the fire is 150 feet. So because of Notre Dame, the Cadet Chapel at the Air Force Academy is 150 feet tall. Sainte-Chapelle, which was the quality of light coming into the building. And the 4th influence on Walter was Assisi. And Walter never believed that you could put more than one chapel in one building and make it successful. Assisi has an upper and a lower chapel. And that's what convinced Walter that it could actually be done. And that's why we have an upper level and a lower level. It's because of Assisi. So Walter came back and started trying to figure out how he was going to design this chapel, and he settled on the use of repetitive tetrahedrons. So a tetrahedron is essentially a three-dimensional truss, and the current chapel, which has 17 spires, is made up of 100 tetrahedrons. So each spire is 4 tetrahedrons. So there's one there, one at the top, then 2 down here, and then the space between the spires is that exact same tetrahedron turned 180 degrees and put in place. The original design with Walter, though, had 21 spires. And the reason for that is he wanted the cadet chapel at the academy to have the same proportion as a cathedral in Europe, and 21 spires would do that. Very early, that became an issue with cost. And so 2 spires were dropped off in favor of 19 spires, which went through design for quite a long time, only to find out that that was still too expensive and was dropped down to 17 spires. And that's the root of the problem that we're trying to fix today. Because the 17 spires was still too expensive. And I'll get to that more here in a little bit in another slide. So Walter's design intent was to use texture, metallurgy of the aluminum, fabrication techniques to create a living building that changes through the day and through the seasons. So the building is constantly changing. You can be there in the morning, it will look one way. In the afternoon, it will look totally different. It depends on where the sun is at and what time of the year it is. And that was one of the key things in the renovation and repair of the project that we are dealing with today, is to try and find ways to replicate what Walter had done back when he did this. And that's been a real interesting challenge, which I'll talk about also. So I mentioned the 17 spires was too expensive still, so there had to be some value engineering, in quotations, things that were done to it. One of those things is that Walter had designed behind the aluminum panels a rain gutter system, a flashing system. So the aluminum on the outside of the buildings was basically a rain screen. Most of the water was shed off. The water that did get through the joints were open, would get to the internal flashings and be carried out. All those internal flashings were all value engineered out in the design in favor of doing 32 miles of caulking. And that's on top of caulk sealants that would normally be used in a building. So think about that. That's from downtown Boulder to downtown Denver, one single continuous bead of caulk. So over the year, and it's never really worked. So over the years, we've had repetitive projects to fix the chapel. So it's kind of like the Golden Gate Bridge. There's the old adage that when you're painting the bridge and you finish at one end, you have to start back at the other end. The same thing was true as caulking the chapel at the academy. We take down 2 or 3 spires a year, take out the old caulking, put new caulking in, and then keep going like that, spending huge amounts of money to do it, only to have it fail again. In addition to that, because of the different sealants that were used and the scraping on the aluminum, the sealants were no longer adhering like they did in the beginning, even though at the beginning they didn't work very well. And then there's also a lot of Band-Aids put on the building, which took away from the original design intent of the design. So the scope of our project is that all of the aluminum on the outside of the building is removed and replaced, every piece of it. Interior finishes, all the acoustic plaster comes out. We're going to replicate the 2 glass walls at each end. And since I had this slide up, one of the interesting things is on this north wall, you can see different tones of bronze glass. Walter did that on purpose. He felt that if you just did one tone of bronze glass on the north wall, it would be boring. So he used the 3 different tones to set up a kind of texture across the glass on the north wall. And so as part of the restoration, which is meticulous, I compare this the restoration of the chapel almost to like a frame-off restoration on a classic car. We're down to every nut and bolt that's correct when it goes back. We mapped every location for every tone of bronze on the north glass, and we're replicating that in the restoration project. The organs are out being fixed, and the pews have all been removed also to be restored. All the acoustic plaster comes out of the inside, which is a huge project in itself, and it has a texture to it. And we've been working with the subcontractor. This is going to be the acoustic plaster subcontractor, going through many, many samples to make sure we got the color and the actual texture right on the new acoustic plaster will go back in. So basically, the chapel, once the acoustic plaster is out, is going to look just like that frame that I showed you with the tetrahedrons. The challenges, obviously our main goal is to eliminate the leakage problem because it's leaked ever since it opened up in '62. Restore it to its original design intent. Recreate that issue of the living building that's constantly evolving. Historic preservation is a big issue. It's probably, I would have to think this has got to be one of the best historic preservation projects in the nation. Now or probably ever. Asbestos is a major concern. Obviously, buildings of this age have a lot of asbestos in it. We knew during design that there was a lot of asbestos in the chapel. We did over 300 tests to determine where the asbestos was while the building was still open to the public. It was all safe. But we couldn't get into some areas without doing destructive testing to the chapel. So the initial contract to restore the chapel had a certain amount of asbestos in it. Now that they've been starting to dismantle the skin and the plaster on the side, we're finding a lot more asbestos. So that all has to be dealt with also, which is kicking the completion date of the chapel down to late 2026. And then as soon as it's done, then we're going to have to move artifacts back into the chapel. So the first time that the public is probably going to be able to get back in the chapel is going to be 27. And obviously a very highly intricate design. It's an extremely complicated building. But the goal is, this is chapel in 1962. Before the restoration, it no longer looked like this because of all the Band-Aids on it. When it's done, we will have fixed the water intrusion problem, and it's going to look like it did when it opened up in 1962. Just quickly, the design team, this is a national effort to restore the chapel. The architect is AECOM from Denver. The contractor is J. Dunn from Kansas City. Interestingly, the company that's restoring all the stained glass is Judson Studios in Los Angeles, and they're the same firm that did it originally. The organ restoration is being done in Georgia. The aluminum skin's being done by A. Zahner Company, which is they do incredibly complex buildings all across the world. I don't know if you've ever seen any of Frank Gehry's buildings like the Disney Concert Hall. They're the people who did that skin on that building. And so we're really great partners with them and really glad they're on the project. The acoustic plaster in Brooklyn, the Air Force Civil Engineer Center in San Antonio has actually let the contract for the construction, so they manage all of the contractual issues with the contractor. The Academy addresses all of the aesthetic architectural issues with the design. And obviously, we're the client. So when J.E. Dunn proposed on the chapel, they were the only firm that actually wanted the project. They're the only company that actually tried to get the project because it's an extremely high-risk project. If you do it well, it's going to be a high-reward project at the end. But when they're trying to put their proposal together, they're thinking, how do we work on this building through all of the seasons and all the weather and all the wind that we get at the Academy and actually get this done without it taking 20 years to do the renovation? And so they kind of jokingly said, well, maybe we should just build a building around it. And then all of a sudden, it kind of hit them like, well, why don't we build a building around it? So this is actually what you're seeing going up, is a steel building with a translucent fabric skin like the terminal roof that DIA has. And so the building is totally enclosed now. And it's pretty awesome to walk into this enclosure and see the chapel inside this building. And ironically, it's the first time that the chapel hasn't leaked. So to talk about the challenge of trying to match the aluminum, there's two characteristics that were really important to the aluminum. One was the color of the aluminum and how it changes. The other was the iridescent quality of the aluminum. It almost has a glow to it. And so, unfortunately, I never asked Walter how he did it. I always thought that it was through the anodizing process on the aluminum that he created that effect. So in design, we went through many, many samples of anodized aluminum panels, and you can see some of them here are actually put on the chapel. And we could never get the color right, we could never get the iridescent quality right. Until the very last batch of samples we got, we put them up on the chapel. And there was one particular sample that was almost dead on in color. We were all out there at the chapel at 2 o'clock in the afternoon, and we were really happy. We hadn't matched the iridescent quality yet, but we thought, well, maybe we're getting close on the color of the building. And so we walked away from that kind of happy because we thought we were way ahead of where we had been. So I left work later that day around 4 o'clock, and I thought, well, I'm going to go back over and take a look at the sample. The color of the sample looked exactly like it did at 2 o'clock. The building behind it had changed because the sun had rotated over to the mountains, and it was not even a close match anymore. So it put us back to being basically, we didn't know what Walter did to create that effect. Then in construction, at that point, we kind of gave up in design, and we knew that J.E. Dunn, being a large contractor, had more access to more companies and resources to be able to figure out this aluminum issue. So J.E. Dunn started doing the samples, and we ran into the exact same problem with them that we did during design. We just couldn't match it. And then at one of the last group of samples we did, Zahner came back and said, well, we did a metallurgy test on it, and the metallurgy's right. And then we did a test on anodization, and guess what? The building's not anodized. So Walter made a conscious decision to let the building oxidize, let the aluminum oxidize, which is what gives it its patina. But since the aluminum has no coating on it, the aluminum still shines, has sheen to it, which is the iridescent quality. And so so that's what we're going to do. So all these infill panels are not anodized. All of what we call the picture frame, which is the trim around them, is anodized. So we matched that anodization. That was easy compared to the infill panels. So when the chapel opens back up in 2027, it's going to look like it did in 62. And it's going to be shinier than it was. And then the patina process is going to start over the years and go back to the tones that it has when we closed it. You can see here some of the details that were covered up. One of the big things in the architectural design was that in between the big spires, there was these little mini spires. They all got covered up with sheet metal because they were leaking. And so that detail has been lost completely since 1962. This is one of the construction workers when the chapel was being built, and here you can see the top of the big spire and the mini spire that goes in between. So this is an example of where we're going with the project. When we finish the project, these mini spires will be back again and visible. As per the Band-Aids, this spire cap, which was the original one, had been covered up with a huge spire cap that was much taller, and it was all just out of bent aluminum, where this is actually very sharp corners, really nicely made piece of aluminum spire cap. And so this is what's being reproduced to go on the final restoration. Here you can see the mini spire again coming up, and it goes back up over the ridge. So one of our other challenges, I talked about the north glass. One of the other challenges is the south glass, because Walter couldn't just use the bronze glass because there'd be too much heat buildup, this being south facing. So it's a kind of a gray tone, and it was the first use of a heat reflective film in a laminated glass system. And it was one of the great things about the Academy project. It was such a huge project that product manufacturers were willing to go the extra step to do something new and create new materials. So that was a Monsanto film that was laminated in the glass, which is not available anymore. So the interesting thing that we have to match is that on the outside of the building, you can't see in, obviously. From the inside of the building looking out, it has to let light in. So once again, we had several glass manufacturers involved now. We've gone through many, many samples with the glass, just like the aluminum. We're getting really, really close with a ceramic frit that's going to have a piece of bronze glass behind it. It's going to be a double pane system. And the latest sample that we looked at last week had a little bit too much brown in it, so we're trying to get more of an aluminum silvery color to it on the next round of samples that comes in, but we're getting close on that. One of the big things that we're doing is restoring all the Dalles de Verre. There's over 22,000 of these individual pieces of stained glass. And they run up between the tetrahedrons and separate the spires from the infill piece from the next spire. Every one of those has to be cataloged and has to go back in its exact same location that it was taken from, because Walter's lighting scheme from the design for the chapel was, as you enter the chapel from the south, it's very dark colored stained glass. As you walk towards the altar at the front of the chapel, it becomes the more gold tones, yellow tones, as though you're entering the arms of God. So that scheme of where those stained glass pieces go is very important to the restoration of this building. So one of the Band-Aids that have been put on it, along with all the others on the aluminum, was these, well, I call it shower door glass, because it was basically an opaque kind of glass, almost opaque kind of a glass with wire in it. That was put over the top of the stained glass to keep it from leaking. So this is what it looked. This is what it looked like originally. Then the system was put on it. This is what it's going to look like after it's complete. You can't tell much difference from there to there, right? Which is what we're trying to get to. So this area is where those covers were put over the stained glass. And actually, the stained glass was recessed down farther behind this area and as the spire comes into it. So it created this really deep reveal, which was critical to the architecture of the chapel. When that storm window system was put in, that totally obscured that reveal. You can also see how much dirt built up over the years between that storm window and the stained glass. One of the other things that we found is that when they put the storm windows in order to get that, they put a frame on the side here all the way up and a frame on the side here all the way up. They basically infringed over it was an aluminum frame, basically infringed over the stained glass. So it actually was blocking 1/3 of the light coming into the chapel. So unless you were actually in the chapel in 1962, nobody's actually seen the true brilliance of the stained glass in the chapel. When we open it back up, you will. This is the interior view of those dolls and the cassettes that they sit in. So there's either 9 dolls in one cassette or 12, depending on where you're at and the height of the building. What's really interesting is I told you that everything had to go back in the same location. You can see a tag that J.E. Dunn put on the cassettes. So every cassette has a number which corresponds to where that cassette is removed from in the building. When they started taking out these cassettes, they found written on the side of the cassette the exact same numbering system that was used to place them originally. So this is inside the chapel. Judson Studios was there removing the cassettes. When they remove one, they put it up against a light and inspect it for any damage, any cracks. There's 6 phases of the restoration. When they're taken out, they're taken to a warehouse in Colorado Springs. The first phase is actually in Los Angeles, now being restored. It's about half done. Out of all the cassettes that have been removed so far and all the ones that are still in place, we only found 16 broken dolls, which is pretty amazing. And most of those, I think half of those can actually be fixed. Now, obviously, it's an historic material. We want to fix versus replace. We will have to replace some, and the dolls came from Blanco glass. on the East Coast. And in talking to them, they actually went out to their shed or where their storage areas, and they found the original molds from the original stained glass. So the new ones that are going to be made are going to be cast in the original molds. So back at Judson Studios, this is a restored cassette. This is an unrestored cassette. It's a huge difference. And these are some of the cassettes laying on their table there waiting to be restored. These are some of the dolls that have been removed. You can tell this one is broken. We can fix that one. This one is in more serious condition here, which is what this one is. Obviously, this is going to be very difficult to try and fix because there's so much damage to it. One of the interesting things that Walter did was he specified that about a third of the dolls that are in the chapel would be chipped like this. That's not hail damage. That's actually meant to be that way. So when light comes in the building, it'll sparkle more. So we're curious at how that was done. So when I was back at Judson Studios in LA a couple months ago, I asked them how they did that. And so they actually got a doll, not from the chapel, but a doll from someplace else, and showed us. So it's basically a hammer that's got an edge to it. And they basically very lightly just tap the side of the glass and you'll get a fragment that comes off of it. And it's just barely a tap. It doesn't take hardly anything at all. So one thing that we did in design was, I think this is going to probably be one of the most tested buildings that's ever been built, because in the end, we want to make sure that it's not going to leak. So we tested our design in Dallas at a facility down there. So we actually built the tetrahedrons and built the panels and connected the panels to the tetrahedron like the design showed, and then pressure tested it with water. And it actually worked. The real advantage that we got from it, though, was some information on better ways we can actually do the connection of the metal. So basically, what we're doing in our design is going back to Walter's original premise, that there will be an internal system behind the aluminum cladding on the outside of the building. So once again, the exterior cladding is going to be a rain screen. What goes behind is going to pick up the water and carry it out. And it works. The one thing that we're doing also next month at the same facility in Dallas, we are doing another mock-up with the current design. And then in August, we're going to be going down again and pressure testing the most current design to make sure that it works. Talk about the pews. There's some symbology to the pews. The end caps on the pews are reminiscent of a airplane propeller. The aluminum cap on top of the back is reminiscent or supposed to be symbolic of an airplane, the tail edge of an airplane wing. And so if any of you know about wood propellers, they're not a solid piece of wood, they're laminates. And you could kind of see where the lines were between the laminates and the wood. And we always kind of thought that, well, it's probably the same species of wood. And I'll show you what we found once we stripped them. So basically, that's the Protestant chapel without the pews. The water took its toll on the pews. This is the worst of it, which is why I took the picture of it. But there's other areas that are similar. So the veneers are cracked. This particular pew is completely rotted out from water dripping out. There's cushions on here, which then held the water, which made the situation even worse. So the pews are actually in a warehouse in Colorado Springs being refinished. And they're not being sanded. They used a really interesting way of getting the old finish off with it's a wash. And it basically takes it down to the bare wood. But what we found, those are the laminates. So nobody's seen that, for decades. And when it goes back, that's what it will be. But it's beautiful. Like I said, you could tell where the laminate lines were. You just couldn't tell the difference because of the yellowing of the finish and the dirt that was on them. As I mentioned, both pews are in, both organs are in Georgia being restored. The big one upstairs, which we knew had water damage to it because there was a lot of leaks at this end of the building. When they took the organ apart, some of the pipes were full of water. And actually, we had a really interesting thing happen. Turning the chapel over for renovation was a pretty emotional thing for the Air Force Academy. And so we thought that there had to be some symbolic passing of the keys to the contractor that was, and the ceremony would be open to the entire academy community. So it was actually, ironically, a rainy day that we had it, and water was dripping, it was leaking, and it was actually dripping on the altar. So we thought, it's crazy, just the timing of this. And then all of a sudden, we were all sitting at the front of the chapel, and the organ went off by itself. And there was some air pressure or something like that, but it gave like several large toots. And everybody's kind of looking at each other like, well, this is really eerie. It's almost like the building was crying for help at the time. So if you walk into the building, this is what you see. You can see the aluminum panels are coming off. All this plastic that's on there with the red tape is where asbestos abatement is happening to seal it off. You can see the DIA kind of fabric here. We're still trying to give a lot of tours to different groups. These are cadets, civil engineering cadets that came in for a tour of the construction. And looking straight up, you can kind of see where there's great primer here. That's the primer for the intumescent paint that's going to go on there, which is fireproof paint. It's going to go on the spires. The asbestos that was in here was used for both insulation and fireproofing. There's 55 semi-truckloads of scaffolding inside the building right now. And you can kind of see it here. You can also see some of the cassettes that have not been removed yet compared to areas where they had been removed. So when I took this picture, it's looking straight up where the altar is. This high floor right here is the 8th story floor out of 14 stories of scaffolding in the chapel. And if you walk in, in a lot of areas of the chapel, you really can't even tell that it's the chapel because it's so sealed off for the asbestos abatement. So that's it. Any questions? I'll start at the front.
So as you are doing this, and I think you're still going to have the aging issues over time. I mean, one of the most things, or to me, was the laminate on the wood. What are you doing to sort of be able to make it be able to be more maintained over time so that 40 years from now, we're not faced with another major restoration? Or is that even possible?
Well, I don't know the technical answer to your question. I know that the specification for the new finish that's going to go on the pews is a lot different than the original, and it's not going to be as susceptible to UV. So hopefully it's going to last a long time. At some point, we'll probably have to take the pews down and refinish them, 60 years from now. I don't know. The building's going to take maintenance like any building does, even when it's done. So
the original building was cut back from 21 spires to 17, and the internal water channeling was removed to save money on the budget. I can't imagine with all the unanticipated costs that you're facing that you have a solid budget, or do you?
I think that we do now. The big question was the asbestos, and we knew going in that was going to be the big question is about if we got the number right on the amount of asbestos in the building, or did we miss a lot and we still have to remove it. And sure enough, we missed a lot. The construction number, 220 million, of which the asbestos modification that we just awarded to take care of the additional asbestos that is in the building, that was $60 million itself. The original cost, it was like 3.6 million. But the asbestos is driving a lot of the budget. And back when the building was built, nobody realized that asbestos would be the problem that it is. In fact, we have a photo of a construction worker that was basically in one of the tetrahedrons. Not that guy, but in one of the tetrahedrons, actually spraying asbestos onto the steel. And he was not wearing any protective equipment, and he was smoking a cigarette.
Sounds like your boss Walter knew Frank Lloyd Wright. Great on design, not so good on structure.
He did know Frank Lloyd Wright.
That's surprising. My question has to do with insulation. If you're taking off the asbestos, what are you putting back in?
It's sprayed on insulation. No, it's a fibrous material. I don't know the exact name of the technical name of the material. Back to Frank Lloyd Wright, though, the fact is that when the Air Force was looking for the firm to design the Air Force Academy, it was shortlisted to 4 or 5 firms. The second place runner-up was a consortium of firms that have been put together by called Kitty Hawk Associates, and they had Frank Lloyd Wright as their primary designer. And we actually found a couple of Frank Lloyd Wright drawings of the cadet area.
2 things. What I'm hearing is the superstructure or the bones are going to remain.
Yes.
The tetrahedrons, and that's really about it, right? I mean,
For the upper floor.
right.
We're not doing anything to the lower
Correct.
floor.
Heating, cooling, cost. What is the design there for a structure like this?
As far as the systems or
You
what
know,
we're doing in the
well,
design?
insulation and stuff, but is there recirculating the heat and the cooling, or is it needed as much?
Well, the heating system was basically a lot of it was changed out about 15 years ago. Some of the old stuff stayed, was still good. We replaced some of the stuff with new stuff. So we didn't really feel as part of this project that needed to happen. It was all still working well.
Huh.
But the north glass and the south glass were all single pane originally. We're going back with a double pane system, so that's going to help. So we are doing some things to make it more energy efficient.
Right.
Anybody else? Anybody online have a question?
Yeah, I have a question. So you mentioned that they had to cover up the mini spires because of the leaking back in the 1960s, but you're going to, they're going to be coming back. And so how are you going to keep those mini spires from leaking this time?
They'll have the internal metal membrane flashing system, which was value engineered out originally.
Okay, thanks.
Anybody else? Well, thank you very much. I appreciate it.